American astronomer Harlow Shapley once believed the Milky Way galaxy was 300,000 light-years across. In the early 20th century, this figure seemed absurdly large, but was actually pretty good for the time, given he was more or less correct in his calculations of proportional distances within the Milky Way and the position of our Sun in relation to the galaxy. His contemporaries said the Milky Way was much smaller than what Shapley had calculated, and if Shapley's figure was 3 times too big, his contemporary, Herbert Curtis, came up with a number 3 times too small. And seeing how we couldn't get the size of our galaxy right, finding the size of the universe was still some time away. Welcome back to our channel, where today we're going to try and understand just how big the universe really is. And if you haven't already, make sure you hit the subscribe button and ring the bell so you never miss a video. When you are discussing distance in light years, it's understandable if some astronomers centuries ago got it wrong. But thanks to their studies and calculations, we now have the means to actually find out what's out there. Today, we're certain the Milky Way galaxy is about 100 to 150,000 light years across, and the universe, of course, is much larger. It's most likely 93 billion light years in diameter, and perhaps still expanding. To put that in perspective, 1 light year equals 6 trillion miles. Just trying to comprehend what the distance looks like is enough to make your brain hurt. So let's start with home. This is Earth. About 295,855 miles away is our natural satellite, the Moon. In the distance between these bodies, we can fit another 30 Earths. And if a road connected all the Earths and you decided to take a trip to the Moon, it would take you 160 days to drive there. And if you wanted to send a message back to Earth, it would take about 1.25 seconds to reach. In comparison, if you were standing on Mars and sent a message to Earth, it would take 20 minutes. If we zoom out further, we'll find Voyager 1, a space probe launched by NASA in 1977. As of September 17, 2020, the probe is 14 billion miles away from Earth, making it the most distant man-made object from Earth. 43 years after its launch, it continues to transmit data to Earth and carry out routine commands. But there's a lot further to go. The observable universe consists of galaxies and other matter we can see from Earth, because light from those objects has had time to reach our planet since the beginning of cosmological expansion. The farther an object is from Earth, the longer it takes for their light to reach us. Some are so far away, it would take billions of years until we finally see it, which means there are objects out there whose light still hasn't reached Earth, which is precisely the issue. We live in a little bubble, and what's outside is unknown to us. We do know the universe is 13.8 billion years old, maybe give or take a few hundred million. That means an object whose light took 13.8 billion years to reach us should be the farthest thing we can see. By that logic, shouldn't the universe be only 13.8 billion light years across and not 93? Well, don't forget the universe is continuously expanding. The amount of time light takes to reach us changes all the time, but luckily, scientists know how much we have moved. So as of now, we have moved 46.5 billion light years away from where we were, based on the expansion of the universe. And because the universe is ever expanding, the outer edges of the observable universe gets further away from us at a speed faster than light, which means they're moving away faster than their light can reach us. Andrew Z. Colvin attempted to bring some perspective of the incredible and ever-expanding universe with a series of drawings, starting with our planet and gradually zooming out from there. So let's start there. Here is Earth, the only known planet to have life, with 71% of our surface covered with water. Zoom out a little, and we have our solar system, gravitationally bound to the Sun. It consists of 8 planets, some dwarf planets, and other smaller objects. It was born 4.6 billion years ago from the gravitational collapse of a giant molecular cloud. Zoom out a little more, and you'll see our solar interstellar neighborhood. It has a radius of 300 light years, and you might be familiar with the stars in this neighborhood: Proxima Centauri, Sirius A and B, and Eta Cassiopeia. Further out, and we have the Milky Way, the galaxy containing our solar system. It looks like a band in our night sky because of its disk shape as viewed from within. Until the 1920s, this is where we thought all the stars in the universe were contained. Of course, we know this isn't true now because as we zoom out, not only does the Milky Way become a tiny speck on the board, we see how many billions of stars there are. This is the local galactic group, where we are, and where the next biggest galaxy, the Andromeda Galaxy, is. The Milky Way and Andromeda move toward each other at a speed of 76 miles per hour. In just 4 billion years, the galaxies will collide. Neither will be able to survive. Even if they survive, the collision will permanently disrupt the flat spiral shapes of both and create an elliptical-shaped galaxy with new constellations and a reddish hue. We would see the collision occur in front of us, and our night sky would never look the same again. It's hard to ascertain the total number of galaxies in the local galactic group, but estimates show that it can go up to at least 80. Further out is the Virgo supercluster, consisting of about 700 galaxies. It has a disk shape resembling the Milky Way and measures 110 million light-years across. It's also moving at a speed of 10 miles an hour toward the M81 galaxy group, the closest cluster of galaxies to us, and residing in the constellation of Ursa Major. Even if we moved at the speed of light, it would take us 11 million years to reach M81. The Virgo supercluster is our best studied cluster of galaxies and is the nucleus of the local supercluster, which we see when we zoom out further. The existence of superclusters proves that galaxies in the universe are not uniformly distributed. Many of them are drawn together into groups, each containing about 10 to 12 galaxies. They generally span between several hundred million light-years to 10 billion light-years across, covering about 5% of the observable universe. Superclusters are the most massive structures we know of out there, and studying them can give us an idea of the initial condition of the universe and how it began. After our local supercluster group, we finally have the observable universe, everything we know of. Our knowledge is limited to everything within this bubble. It's a spherical region of the universe comprised of objects that can be viewed from our planet or seen with the help of space probes. There are about 2 trillion galaxies in this space, together containing more stars than the grains of sand present on the whole Earth. The diameter of our observable universe is estimated to be about 93 billion light-years, and though in principle we should be able to see more galaxies in the future, a lot of them would have shifted due to expansion and therefore have become invisible. The observable universe is probably just a tiny slice of the actual universe. The theory of cosmic inflation put forward by Dr. Alan Guth suggests that at its early moments the universe expanded faster than the speed of light. Even objects now far apart from each other were once in close contact. It is estimated that in the present day, the size of our universe is 150 sextillion times larger than the observable universe. It's hard to fathom what that even looks like. Beyond this observable universe could be something unbelievably fantastic, but we might never know. As the rate of the universe's expansion increases, whatever is observable to us currently will eventually appear to freeze in time while emitting redder and fainter light. We have to accept that the light from some objects too far away will never even reach Earth. This means events that transpire over 16 billion light-years away from us would remain a mystery. The little part we can see might be all we'll ever observe. And at this point, we are lost. We are indistinguishable from the hundreds of billions of dots on the map. One of these dots, a pale blue one, houses intelligent species, but you would never be able to tell. Here, you can't see humans or their creations. It's just merely a lump of rock as far as anyone is concerned, spinning about. The sheer size of the universe is enough to humble us, but fascinating enough for us to be curious too. In our curiosity, we have had over 800 space missions, and what started with the first crewed mission to the moon has now led us to discovering water on the moon. We have billionaires planning to settle colonies on Mars and the possibility of space hotels. It takes us nowhere near the edge of the universe for a peek outside, but it does bring us closer to understanding its boundlessness all the same. If you enjoyed this video, be sure to hit the like button and check out our other videos just like this on our channel. Thanks for watching, and we'll see you next time.